Okay, here we have question number 4. A teacher was marking the exercise book of a student who had completed a topic of work on acids and alkalis. The table below shows the results the student had recorded from an experiment to investigate the pH values of some common laboratory chemicals. The teacher has circled 3 errors for the student to correct. Okay, so we've got this error here. We've got ethanoic acid, which is also what you know as vinegar. Okay, it's called an organic acid, and it's got a pH that suggests it's a weak acid. Okay, and yet the student has recorded it as an alkali. Then we've got water. Okay, water as the formula H2O. We would expect that colour green if you placed universal indicator into water, because water is neutral. However, the value of pH for neutral solutions is 7. Okay, and then sodium carbonate, okay, is an alkali. We would expect this pH, we would expect this colour of universal indicator. However, sodium carbonate, the sodium ion is Na+, and the carbonate ion is CO3 2-. So we need 2 sodiums for every carbonate. So that should read Na2CO3. Okay, so if we correct those errors here, so error 1, it should be weak acid or acid, as there's no weak or strong in the table. Error 2, that should be a value of 7. And error 3, the formula should be Na2CO3. Okay, you can check that against the table of ions on the exam paper or in your book to verify that that's the correct formula. There is another error in the table that the teacher has not spotted. Easily done. Circle this error in the table. Okay, so if we have a look at the first line of the table, we've got sulfuric acid, H2SO4, that's correct. However, we wouldn't expect universal indicators to go green in H2SO4. That's the colour we would normally associate with neutral solutions like water. If it's a strong acid, and that's what the pH 1 tells us, and that's what sulfuric acid is, we would expect that to be red. Okay, so we'll circle that, and for the sake of completeness, we could write red there as the correction. Okay. So moving on, this is a big question, this one. Another piece of work in the exercise book showed the results of some tests that the student had carried out to identify some of the ions in the chemicals being investigated. However, the table has not been fully completed by the student. Okay, so ion being identified, so carbonate ions, we add hydrochloric acid, and we expect to see bubbles formed as carbon dioxide. Okay, so the CO3 2- ion is almost carbon dioxide, just with an additional oxygen atom, which goes on to become part of the water in chemical reactions. So this is carbon dioxide, which you are familiar with. However, the next one is a reaction we do need to do. Okay, the sulfate ion, as found in excuse me, in sulfuric acid, the test for that is to add this chemical here, barium chloride. And when you add barium chloride, you get a white precipitate to show that the sulfate ion is present. Okay, so that is something that you would be unfamiliar with unless you did some research or looked that up. Okay, so barium chloride is the test for the sulfate ion. Okay, describe the test that can be used to identify the gas produced when hydrochloric acid is added to a compound containing carbonate ions. Now, we did see one test in the previous question that it will extinguish a lighted splint, and it's heavier than air, but a more reliable and a more common test would be bubble the gas through lime water. So that's the test, is bubbling it through lime water. And then usually when you're asked about this, you need to describe the test, but you also need to describe the result. And the result is that the lime water goes cloudy. Okay, so that's those are the answer to that question. Okay, now then, this question here again talks about temperature change. Okay, so this is obviously on a higher question. This is mixing a number of different topics together. We saw last year evidence for chemical reactions, including temperature change, colour change, and the effervescence of a gas, or the evolution of a gas and effervescence. So the final piece of work marked by the teacher was an experiment that had been completed to investigate the temperature change when different metals react with hydrochloric acid. The graph shows the results obtained by the student shown below. So we can see in one reaction, the temperature change was quite large. It starts at 20, which is room temperature, and it peaks around about 53 degrees Celsius and then drops off again. Okay. And then we've got an intermediate value, and then we've got one where no temperature change occurred, which would suggest that no reaction happened. So the questions say, use the graph to give the letter of the metal that did not react with hydrochloric acid. So this graph here remains steady at 20 degrees Celsius, which is room temperature, would be the metal that did not react. So that's metal C. The maximum temperature rise for metal A. Now here you need to be careful to quote the temperature rise, not the actual temperature. So it starts at 20 and it rises to, I think we've got there, that's 51, 2, 3, so 53. So 53, take away 20, gives us 33 degrees Celsius. Okay, and then state the term used to describe a reaction that gives out heat. Well, that's exothermic. Okay, where thermic is the heat and exo is out, as in exit is the way out. Okay, so heat is given out. Okay, I think that's the last part of that question. Oh no, sorry, there's more. When metals react with acid, they form a salt and hydrogen gas. Complete the word equation for the reaction between magnesium and sulfuric acid. So this question is expecting you to know that when you react any metal compound with sulfuric acid, you always get a metal sulfate. Okay, so sulfuric acid makes sulfate, and in this instance, it's magnesium sulfate, and it's a word equation. So don't put in a chemical formula, otherwise you won't get the mark. Okay, so you need to answer the question as stated. So magnesium sulfate is the salt created. Give the test that can be used to identify hydrogen gas, including the expected observation. Okay, so we introduce a lighted splint. So that's the test, or splint to the gas. To be absolutely clear, this produces a squeaky pop. So that's the key phrase there. That's the actual result, is the squeaky pop sound that we all are familiar with. Now, the salt formed when zinc reacts with hydrochloric acid is zinc chloride. Give the formula of the ions present in zinc chloride. Okay, now this is not necessarily a memory question. You can use the table of ions present in the exam paper on the day or in your book when you're doing these sorts of questions. And if you do that, you'll find out that the zinc ion is Zn 2+. Okay, and it's important that you put the 2+ in the right place. It's a superscript after the symbol. And the chloride ion is Cl- or 1-, but you don't need to write the 1. The solitary minus will do. And then if we look at these two ions and we apply our little seesaw idea, then we can see that in order to balance the 2+, we would need 2 Cl-, and that would give us the formula of ZnCl2. And again, it's important you put the 2 in the right place. It's a subscript after the element it refers to.